Okay, so today we are talking about parent functions. We're going to draw them quickly and accurately. Okay, so this guy right here, this guy is a piecewise function. He's a piecewise function because there is a certain equation of a line that makes this, and then he stops, and there's a new equation to make this, and then that stops, and then a new equation of line to make this, and then that stops. So the pieces together make this function. This is a linear function, and this guy is an exponential. So these are all functions because when I use the vertical line test, which is moving my pencil from left to right across the graph, if I only touch one spot of the graph at a time, then that passes the vertical line test. So these are all functions. Linear is what we talk about in 8th grade. We use the slope-intercept formula, the y equals mx plus b, and exponentials have some sort of exponent in their curve. And we're going to talk more about piecewise functions and how to graph them in a few days, but not today. So the first thing that you need to know, or the first thing that you need to remember, is that if you have f of x, it's the same thing as y. Okay, so they're interchangeable, f of x and y. We use f of x for like plugging in stuff, and we use y for like the equation and writing it. Oh man, sorry. Okay, so functions make shapes when we graph them. And the shape is just the picture of all the points that make the function. It's not necessarily like a circle because a circle would not be a function. Okay, so we're going to talk about some parent functions. So parent functions are like the major guys. They're the most basic of them, and they usually have special names. So the first one we're going to talk about is we're going to talk about quadratic functions, and usually you see them as f of x equals x squared or y equals x squared. So this is going to be kind of our focus today as we finish talking about the other parent functions. Now, when you're graphing these, it's really great to use the ordered pairs or the x values of -2, -1, 0, 1, 2. This will keep us close to the origin, the center of our graph, and still allow us to see the picture. All right, so what we're going to do is we're just going to plug these guys in for our x value and see what our new y, or f of x value, will be. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So we're going to graph those ordered pairs on here. -2, 4 is here. -1, 1, 0, 0, 1, 1, and 2, 4. After this, we connect our dots, and now we have a parabola. This is the first parent function we are going to talk about. Okay, so this shape is called a parabola. And the center point of the parabola is called the vertex. And on the parent function, it's at 0, 0. So this guy right here is our vertex. So how you graph these parabolas, it's the same for all of the parent parabolas. So anytime you see x squared, basically. So you're going to graph the vertex at 0, 0. Then from the vertex, you're going to go to the right one and then up 1. And then again, from the vertex, you're going to go to the right 2 and then up 4. That's the pattern. And that pattern will be helpful when we do our next activity. Okay? All right. Then this also has a line or an axis of symmetry. So if I cut this parabola right down this line right here, and then I fold it in half, all my points are going to match up, and then all the way up. Like, it's going to keep going forever. So this has an axis of symmetry on the y-axis, or where x is equal to 0. Okay, so this is our first parent function. Then we have this guy, and this guy is an absolute value. Okay, so remember, absolute value means distance from 0. Okay, so -2 is 2 spaces from 0, -1 is 1 space from 0. 0 is 0 spaces from 0. 1 is 1 space from 0. And 2 is 2 spaces from 0. So basically what's going to happen here is we have a lovely V shape. We start at 0, 0. Again, that is our vertex of our graph. And then we're going to go to the right 1 and up 1 and to the right 2 and up 2. And then the same this way, left 1, up 1, left 2, up 2. And we have our absolute value graph. So this is the absolute value. And it just looks like a V. Let's see. Okay, let's go to this page. Oh, I don't want to do the top part. Okay, now we have square roots. So square root parent function is a little bit different. And the main thing that's different here is we can't have negatives for our x's because that would give us imaginary numbers. And we are not graphing imaginary numbers today. So the other thing is if you would like to have pretty square roots, then you have to use pretty numbers. So this is our x value that will go underneath the radical, and then this is our y value. So this x value is like our area, and the y value is the side length of our square, because remember, squares have the same measurement. So if 4 is my area, what is my square root? Well, this would have to be 2 and 2, right? Because 2 times 2 is 4. So over here, if my area is 4, then my root was 2. If my area is 0, my root was 0. If my area is 1, my root is 1. If my area was 9, my root was 3. And again, we are not doing imaginary numbers today. When you graph these, because these all have to be positive values, we're going to start at 0, 0, and we're going to go to the right 1 and up 1, to the right 4 and up 2, and then if we could, we would go to the right 9 and then up 3. So this is going to be an exponential curve, but just a piece of it, and it's pretty shallow all the way across. Okay? That's a little different than the cube root. Now the cube root is special, or it's, I guess, just different. With the square roots, right, you can only have 2 numbers, so they have to be the same sign. But with cubes, you can have 3 numbers. So not only could we have -1 as an area of a cube, but you could also have -8 or +8. Because -2 times -2 times -2 will give us our -8. With 3 negatives, we can have negatives here, and it's totally fine. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1, and the cube root of 8 is 2. So we're putting this x value in here, okay? Now we're going to graph, and you'll see this one is a tiny bit different than our squared, but still kind of the same feeling. So we have a dot at -8, -2, -1, -1, 0, 0, 1, 1, and all the time on these cube roots, you'll see this cute little line, and he'll kind of shift a little bit, but you'll see him there. And then we have 8, 2, and they're kind of like curvy little friends, just like our square root, okay? Now, this guy has rotational symmetry, which is pretty nifty, around the origin, which means if I take this guy and I spin him around like this, well, now it looks like the same graph, okay? So sometimes we can be tricked, or like if we graphed it and we didn't know what happened or what we did to change it, because it has this rotational symmetry. Whereas this guy, if I rotate him in any way, shape, or form, he's not going to look like the parent function. So I know how it was moved a little bit easier than figuring out how our cube roots are moved if I don't give you the equation. Now the last examples, we need to just go over a few basics that we kind of already talked about a little bit on the front side. Anyways, the graph of y equals -2, so that's everywhere an ordered pair has, +2, sorry. Everywhere an ordered pair has a y of 2. So for example, 4, 2, because remember it's x, y. So anytime the y is 2, -1, 2, 0, 2, 8, 2, everywhere this y will be 2 will be on this line. So anytime that y is equal to a number, it's a horizontal line. And then this guy, x is equal to -3, so we want all of our x values to be negative 3. So negative 3, 4, negative 3, 8, negative 3, 0. All of the x values in the ordered pair are going to be negative 3. And in that case, that gives us this guy right here, which is a vertical line with an undefined slope. So when x is equal to a number, it's a vertical line. Also, everything that we've talked about before have all been functions, except this guy is not a function. And the reason he is not a function is because he fails the vertical line test. When I sweep my pen from left to right, I touch all the picture of my graph at the same time. So this guy is not a function, whereas the rest of these guys were. Okay, so that gives you a little information about parent functions and what they look like. If you have any questions, let me know. Have a great day, guys. Bye.